Assalamualaikum and a good day to all. So I'm going to explain to you on how to use the Kirchhoff law for different kind of questions. So I randomly pick like 5 questions from extrapolative Kirchhoff law. So hopefully this video going to give you a better understanding on how to use the Kirchhoff law. Okay, so let's start. Okay, so for the first question, they ask you to find the current I1, I2, and I3. Okay, but now the switch S is basically open. So when the switch S is open, what happened? Yes, it means that there will be no current flow here. Current flow. So it means that there's only a current flow in this region only. Okay, so it means that the current flow at the yellow line going to have the same value. Okay, so you can actually use the concept of Kirchhoff law because you already learned that for you to solve these questions. Okay, so it means that you are going to draw one big loop. Okay, so just to revise everything back, okay, please take note, you need to draw the assumption loop first. Okay, so when it comes to the resistor, if the assumption loop and the current inside the circuit is in the same direction, then your potential difference there going to be negative IR. Okay, but if your resistor if your assumption loop in the opposite direction with your current inside the circuit, so I'm going to put as a CC, is going to have a positive potential difference. Okay, that one is going to be for resistor, whether it's going to be external or internal resistor. You can actually use this concept. Okay, so another tool going to be for the potential difference. It can be for any power supply. So example, if you have a battery, so for the battery, please take note, we are going to look at the assumption loop. Okay, so if your assumption loop is moving from lower to higher potential energy or potential difference, it means that your potential difference there going to be positive. Okay, if you have a battery and your assumption loop is moving from higher to lower potential difference, which is between the terminal, I'm not saying about the circuit, it's between the terminal, then your potential difference here are going to get negative. Okay, so hopefully these 4 concept you memorize. Okay, you remember that, and then you can actually use that for the Kirchhoff law. Okay, so let's start. Okay, so like I mentioned before, we already draw the one big loop over there, so it means that we are going to start at this part. So because my assumption is moving from lower to higher, so it means I'm going to get positive 12. Okay, and then this one I'm going to get negative because it's moving from higher to lower potential energy or potential difference. Okay, 9. And then okay, please take note, the current I2 and I1 going to have the same value because this is already in series, so the current flow will be the same value. Okay, so I just put it as an I only. Okay, so at the resistor, okay, my assumption loop is in the same direction with my current inside the circuit, therefore I'm going to get negative 8I. Okay, and then there's no resistor here. Okay, there's one here, so because in the same direction, assumption loop and also my also current inside the circuit, therefore I'm going to also get negative 7I. Okay, I didn't put I1 or I2 because like I mentioned before, the current there's going to be the same value. Okay, equals to 0. Okay, so you are going to get the value for I, which means that you are going to get your value I is 0.20 ampere. Okay, as simple as that. Okay, but now we are going to do a little bit, okay, right? But now we are going to answer for the second one where the switch S is already open, it's already closed. Okay, so I'm this one. Okay, so like I mentioned before, once you close this thing, so means that there are definitely a current flow here because you can see that this is basically parallel. Therefore, the current I2, I1, and I3 will have different value. Okay, so like mentioned before, if you have 2 empty space, definitely you are going to have 2 assumption loop. Okay, so I'm going to draw one assumption loop here and one assumption loop here, so both going to be in clockwise. You can either draw one clockwise or one anti-clockwise or both anti-clockwise, it's up to you. Okay, so I'm going to start with my first assumption loop here. So my current flow, my assumption loop moving inside the battery going to be lower to higher, therefore I'm going to get positive. Okay, so I'm going to put it as positive. Okay, and then it goes here. Okay, so here you need to understand that in this part the current flow is for I3. Okay, in this part the current flow for I1, because you can see that this is like one series, okay? And this one, the current flow here going to be I2, okay? So please do not confuse which current that you need to write, okay? So, okay, here there are 4 ohms here, and the current assumption loop and the current inside the circuit is totally in different opposite direction. Therefore, I'm going to get positive for that. So I am going to have positive for I3. Okay, there's no more resistor there, there's no more battery. Okay, then I'm going to be put here, this is in the same direction, therefore I'm going to get negative 7 I1 equals to what? Equal to 0, based on concept Kirchhoff voltage law. Okay, so here I'm going to rearrange back. So for I3 minus 7 I1 equals to what? Negative 12. So this is going to be my first equation. Okay, next I'm going to find the second equation based on my second loop here. Okay, so focus loop. Okay, wait, I'm going to draw it again. Okay, and then okay, so I'm going to start from 4 ohms because in the same direction, assumption loop and current inside the circuit in the same direction. Therefore, I'm going to get, yes, good, it's going to be a negative value. So negative 4.0 I3. Okay, and then we are going to focus on this one, which means that we are going to focus that on assumption loop, which is moving from higher to lower. So it's going to be negative 9.0. And for this one, okay, in the same direction with the assumption loop, therefore I'm going to get negative 8.0 I2. Okay, there's no more battery or resistor, double check everything, then definitely equals to 0. So I'm going to rearrange this thing. So I'm going to get negative 8.0 I2 minus 4.0 I3 equals to 8.0. Sorry, equals to 9.0. Okay, sorry. Okay, I'm going to write it again. 9.0. Okay. Okay, so okay, now we have like first equation and second equation. Like I mentioned before, you need to okay, you need to insert this one formula which is come from Kirchhoff currents law. Okay, so Kirchhoff currents law means that you are going to look at the junction whether it's going to be A or B. Just choose one. Okay, so example, if I choose A, so currents going into the junction going to be positive, current leaving the junction going to be negative. Therefore my Kirchhoff currents law here going to be I1, okay, because into the junction, minus I2 because leaving the junction, I3 is into the junction, so it's going to be positive equals to 0. Okay, so for me to find the I3, I1 and I2, I3, therefore I need to use the simultaneous, or I can actually use the calculator. But before you use that, you need to change the unknown here to have the same unknown. So it means that like I3 here is also I3. Okay, so don't disturb that. Okay, the one that you're going to change is the one that have a different unknown, which is either can be I1 or this one can be I2. So it's up to you. Okay, example, if I want to change I2, so here I'm going to have I2 as my subject, which is I2 equals to I1 plus I3. I'm going to insert that into this formula. So I'm going to get my formula is negative 8.0 I1 minus 8.0 I3 minus 4.0 I3 equals to 9.0. So I'm going to get here is negative 8.0 I1 minus 12.0 I3 equals to 9.0. Okay, so you already have the same unknown for both equation 1 and I put it as equation 3. Therefore, you can actually put that in your calculator, which means that you are going to use mode, okay, and then find the equations, okay, equations, and then choose unknown, which is 2 because you have I1 and I2, and then you just insert all the numbers. Supposedly you are going to get your I1 is 0.931 ampere, and I3 you are going to get negative 1.371 ampere. Okay, like I mentioned before, if you get negative value, so it means that the negative represent the current the inside the circuit is wrong, is basically given in the wrong direction. So now you need to understand that your assumption loop is always correct. Okay, the one that's going to be wrong is going to be the current that already draw it for you inside the circuit. So now my I3 is negative, which means that this direction is wrong, which is going to make the Kirchhoff current law not going to be equals to 0, because the current going into will be equals to the currents going out. So it means that if I want to have currents going into will be equal to currents going out, this one need to be in the opposite. Okay, so therefore it should be downward. Okay, please give a statement like the current of I3 should be downward. Okay, like that. Okay. Okay, and then once you find I1, I3, definitely it's not hard for you to find the I2 based on this equation. So you just put it inside your calculator. I2 equals to, to put it inside the formula. So you are going to have 0.931 minus 1.371. You are going to get negative 0.540 ampere. Okay, and if you get negative, definitely you need to give a statement. So it means that I2 should be moving upward, or you can actually say that it's moving anti-clockwise. Okay, but for only for negative you need to give a statement, but not for the positive one. Okay, so okay, like that. Okay, okay, so done with the first question. Okay, and we move on to the next one. Okay, so the next one is the question 3. Okay, this one is a little bit different because you have a voltmeter and ammeter that are connected inside the circuit. Okay, so I assume that this voltmeter and ammeter is ideal, which means that there will be no internal resistance. So example, if the question state ideal voltmeter, ideal ammeter, definitely there will be no internal resistance. Or if the question didn't state anything, you can actually assume that it's ideal. Okay. Okay, so we are going to draw an assumption loop here. So basically, you don't have to be bothered about this part. Okay, you just assume there's no voltmeter there. Okay, you just can draw it like one bigger loop here and one bigger loop here. Okay, because the voltmeter there is just to measure how many potential difference passing through from A to B. That's all. Okay, okay. So I'm going to start with the first loop. Okay. So okay, so we are going to start with the with the 12 volt. Okay, so it's going to be negative because my assumption loop is moving from higher to low potential difference, so it's going to be negative 12. Okay, and the resistor here, okay, resistor here is R, and they already give you the value here, which is 5 ohm. Okay, and my assumption loop and my currents is in the opposite, so it's going to be positive. Okay, very good. Okay, positive 5I1. Okay, and then okay, you don't have to be bothered about the ammeter. Ammeter just to measure the current flow over there, which is measure I1 over there. Okay, and then goes here. So my EMF here is 20 volt. Okay, and my assumption loop is moving from higher to lower, so it's going to be negative 20. And then my resistor here is because, okay, my assumption loop and the directions of I3 in the same direction, therefore it's going to be negative 2 I3 equals to 0. Okay, rearrange everything. Okay, so you are going to get here is 5I1 minus 2 I3 equals to 32. Okay. Okay. Okay, so we are going to proceed with the second loop. Okay, so the second loop, like I draw before, I draw it clockwise, right? Okay, I'm going to, okay, sorry, clockwise. So I'm going to erase this thing first. Okay, so now we are focusing on the second loop, which is moving in clockwise motion. Okay, so I'm going to start with this 2 ohms here. So it's going to be opposite because it's going to be positive because my current inside the circuit and assumption is opposite direction, so it's going to be 2.0 I3, and the EMF here is moving from lower to higher, therefore it's going to be plus 20. Okay, and then for 7 ohm assumption loop and the current I2 opposite, therefore is going to be positive 7 I2. Okay, and then the 8 here, because my assumption loop is moving from lower to higher, therefore I'm going to get positive 8. Okay, I think that's all. Okay, so double check everything, make sure that you didn't left any resistor or internal resistor or battery. Okay, and it's going to be equal to 0. So simplify everything, so you are going to get here is 7.0 I2, this is I2, okay, plus with the 2.0 I3 equivalent to negative 28. Okay, so like I mentioned before, for you to solve this question in your calculator, definitely you need to make sure that the unknown is same for both equation. Like this one I1 and I3, this one is I2 and I3. Please do not disturb the one that have the same unknown, which is I3 and I3 here. The one that you need to change is either I1 or I2 here. Okay, it depends on the equation that you get. Okay, so how to change this? Definitely you need to use the Kirchhoff currents law. Okay, so we are going to choose one junction here. Okay, so you can actually either choose the E here, or you can actually use the C here. It's up to you. Okay, so example, if I want to choose C here, so the currents going to be positive, currents leaving going to be negative. So I1 going to be negative because it's leaving, and the I3 is also leaving, so it's going to be negative I3. Okay, and then I2 is going into the junction, therefore it's going to be positive, equals to 0. Okay, so now I'm going to change this one. Okay, and then for me to change that, therefore I need to put here as I2 as my subject. That's why I'm going to get I2 equals to I1 plus I3. I'm going to insert that into this formula, so I'm going to get is 7.0 I1 plus 7.0 I3 plus 2.0 I3 equals to negative 28. Okay, so I'm going to get my new equations will be 7.0 I1 and plus 9.0 I3 equals to negative 28. So this is going to be my third equation. Therefore, I'm going to insert this one and this one into calculator. Okay, you can actually use simultaneous if you want to, but to make it easier, you can actually use calculator. Okay, so supposedly you are going to get your answer for the I1 will be 3.932 ampere, and for the I2 you are going to get I3 negative 6.169 ampere. Okay, like I mentioned before, if you get negative, please give a statement. So I3 is moving anti-clockwise, so I can actually put here current should be moving clockwise motion, like that. Okay, so only for the negative that you need to give a statement, but the positive one you don't have to. Okay, next is you need to find I2, so you can actually easily find it using this equation. Okay, so the I2 going to be I1 is 3.932 minus with 6.169. okay, for this one, for you to find the unknown, make sure that you use the negative also, which means that you use the wrong direction first. But example, if you need to find the potential difference and also terminal voltage, definitely you need to change the direction to the true direction first, the correct direction, and then you start the calculation. Okay, so I'm going to get here is negative 2.237 ampere. Okay, like I mentioned before, negative you need to give a statement, so the current for the I2 should be clockwise because now it's moving anti, so now it should be clockwise. Okay, so but the question asks you to find what is the voltage across AB. Okay, what is the voltage across AB, which means that the question asks you about potential difference from A to B. Okay, so like I mentioned before, if you need to find the potential difference, make sure that the currents or the unknown that you get negative, you need to fix that direction first, then you start the calculation. Okay, so this one. Okay, so I'm going to fix the direction first, which for the I3 it should be clockwise. So my I3 here should be anti-clockwise, right? It should be clockwise, yeah. Okay, or I can actually put it as moving downward. Okay, actually put like this, it's better. Okay, I think it's maybe downward like this. Okay, downward. Okay, and then for the I2 is also negative, therefore it's going to move upward. It's like something is moving like clockwise motion. Okay, once I done with that, okay, it's better for me to choose two directions for me to find the A to B. Okay, you can actually use one, but to make sure that your calculation is correct, to make sure that your I1, I2 and I3 is correct, definitely you need to use two paths for you to find the correct answer, which is from A to B. So either you can actually use, oh my god, okay, so you can actually use, okay, A to B here, or you can actually use A to B here, or you can actually use A to B here. You can choose any path. Definitely you are going to get the same answer if your I1, I2 and I3 is correct. Like that. Okay, that's why I'm encouraged students to choose two paths. Okay, it's much better and it much safe. Okay, so example, I choose this one first. Okay, I choose this path first. So I'm going to get, here is so I'm going to like draw it like one bigger loop from A to B. Okay, so it's going to be 20 positive because it's moving from higher to lower. And then for the 7 ohm here, because my assumption loop and the true direction is in the same direction, therefore I need to put -7. I2 value is what? 2.237. Okay, equals to what? Going to be equals to 4.341 volt. Okay, so let's check with another path whether we are going to get the same answer or not. Okay, example, if I choose this one, A to B. Okay, so I'm going to start at 2 ohms there. Okay, so 2 ohms going to be positive because my assumption loop and the correct direction is in opposite. Therefore, I'm going to get there is 2 multiplied with the I3 value, which is 6.169. 6.169. Okay, and then minus with 8. Okay, because it's moving from higher to lower. Okay, so I'm going to get here is 4.338 volt. Okay, the difference is only for the decimal place. Okay, it's okay, still you are going to have the same answer because 4.34 and 4.3338 is not that far. Okay, therefore it means that your I1, I2 and I3 is correct. Okay, that's how you find the potential difference. Okay, if example, if you get one is negative, one is positive, you don't have to worry about that. It's only because of the path that you take, because it means that from A to B, supposedly if you get negative, it means that the directions of your drawing is wrong. Example, if I draw like this, okay, if I draw like from B to A, definitely I'm going to get negative, something like that. Okay, so let's move on to the next question. Okay, next, okay, so this question asks you about potential difference, okay, and then also terminal voltage. Okay, for you to find the potential difference and terminal voltage, make sure that you need to find the unknown, which is I1, I2 and I3. But you need to understand that there are certain questions that you need to find the EMF, but they are going to give you another one value of current. But your questions, the maximum unknown can only be 3. Okay, cannot be more than that. Okay, that one is going to be like too advanced. Okay, so we are going to find the unknown first, which is I1, I2 and I3. So I'm going to draw one big loop here. Okay, so like this. So I'm going to start with this one, which is the first loop. Okay, so I'm going to get my equation is this one. Okay, so I'm going to start with 34. Okay, is in the same direction, therefore I'm going to get negative 34 I1. Okay. Okay, and then there's no more resistor over there. Okay, so I'm going to focus at this part, which is this is the direction for the I3, for the current of I3. Okay, so 45 is going to be positive because it's moving from lower to higher. My assumption loop, positive 45. Okay, and then for 1 ohm and also 47 ohm, okay, is in the same path, which means that they are going to have I3 as the current. Okay, and the current flow for the potential difference there is going to be negative because my assumption loop and also my current flow is in the same direction. Therefore, I'm going to get negative. So to make it easier for me to write, I'm going to put like negative there, and I'm going to like just add up 1 plus 47 here, I3 to 0. Okay, the reason why I'm going to write like this is because it's much easier, one, and the reason is because it's much safe. Okay, because I I'm not tend to forget the resistor, because this is like 2 resistor. You can actually have like 5 or 10 resistor, depends on the question. Okay, once you're done with this, definitely you need to rearrange. Then you are going to get here is 34I1 plus 48I3 equals to 45. So this is going to be your first equation. Okay, then move on to the next one. Okay, move on to the next one. Okay, so the second one, I'm going to draw it counterclockwise. Okay, clockwise like that. Okay, so this one here, I'm going to draw counterclockwise. Okay, so the second one, I'm going to start with which part? I'm going to start with at this area first. Okay, there. Okay, so the 47 over there going to have, okay, 47 and 1 going to have negative value, because my assumption loop and my current the current inside the circle is in the same direction. Therefore, it's going to be negative 47 plus 1 I3. Okay, and for the assumption loop here is going to move from lower to higher, so plus 45. Okay, and I'm going to focus in this part. Okay, so 18. Okay, because my assumption loop and my current flow in the same direction, therefore I'm going to get negative for that. So negative, okay, 18 plus 1. Okay, because it's in the same path, definitely they are going to have the same sign. Okay, so don't forget with 75, because it's moving from higher to lower, so it's going to be negative 75 equals to what? 0. Okay, double check everything, make sure that you didn't left any resistor or voltage value there. Okay, so once you're done with the, this one I need to put I2 here. Okay, so once you're done with that, you need to rearrange everything. Therefore, you are going to get here is 48I3 plus 19I2 equals to 120. So let's change the unknown first. Okay, now we can see that the I3 here, the I3 here have the same value, so we don't have to disturb that. Okay, we don't have to change that. So I can only change I1 or I2. So definitely I'm going to change I2, but first I need to come up with the Kirchhoff currents law. So I'm going to choose A as my junction. Okay, so here, so it's going to be negative I1, negative I2, because both is leaving the junction, but plus with the I3 because into the junction equals to 0. Okay, so I'm going to put I2 as my subject. So I'm going to get here is I3 minus I1. Okay, once I get this, I'm going to insert that into this equation. Therefore, I'm going to get my new equation as 8I3 plus 19I3 minus I1, okay, equals to 120. Okay, so I'm going to get the answer is negative 19I1 plus with 67I3 equals to 120. Okay, so I already have the equation, therefore I'm going to put that inside the calculator, which is this one and this one. So I'm going to get my I1 is negative 0.861 ampere. Okay, because it's negative, therefore I need to give a statement. So the I1 is moving clockwise now. Okay, therefore I need to put should be anti-clockwise. Should be anti-clockwise. Okay, so for the I3, I'm going to get is 1.55 ampere. Okay, positive, you don't have to give a statement. Okay, then you need to find the I2, which means that you are going to easily find it using this equation. Okay, so here you are going to get is I2 equals to I3 is 1.55 minus with 0.861, then you are going to get here is 2.411 ampere. Okay, once you find I1, I2, and 3, definitely you can actually find the potential difference between point A and point D. Okay, so point A and point D. Okay, so for you to find point A to D, you can actually choose any path. So I can choose this path, or I can choose this path, or I can choose this path. Okay, make sure that you choose two path, okay, because it's going to you can actually use that to check whether your answer is right or wrong. Okay, okay. So I'm going to choose this one first. Sorry, this one first. Okay, so I'm going to do like one big loops like that. So it's going to be like this from A to B, one big loop. Okay, but before you do that, it's better for you to fix the direction. If you have negative, definitely you need to change that. So I1 is basically anti-clockwise, so my direction now here going to be like this. Okay, okay, example, if you choose that path lah. Okay, okay, so we are going to find the potential difference, which means that here, okay, lower to higher, so it's going to be 75 positive. Okay, and then it's going to be 1 ohms and 80 ohms. Okay, my currents in the same direction with my assumption loop here, so I'm going to put negative there, which is negative 1 times with the value of the current they already found it, which is I2 is 2.411, minus also with the 18, 2.411, and then just put it inside your calculator. Therefore you are going to get 29.2 volt. Okay, so I'm going to choose second path to check whether my answer is correct. Okay, so I'm going to choose this one path. Okay, so I'm going to choose this one. So I'm going to put it here is 47, opposite with my assumption loop, the yellow one. Okay, but make sure that, okay, you need to draw new loop for potential difference. Okay, you don't have to use the assumption loop. You have draw before when you need to find the I1, I2 and I3. You need to draw a new loop. Okay, okay, so 47 going to be positive 7, and multiply with the value of I3, which is 1.55. okay, and then okay, 1 also there should be positive because opposite direction, sorry, 1.55. okay, and then my 45 volt over here going to be negative because it's moving from higher to lower. Negative 45 equals to what? 29.2 volt. Okay, so basically it's almost the same value. Sorry, it should be 29.4 volt. Okay, it's only decimal place. Okay, so basically what happened here is your answer for I1, I2 is correct. Okay, because you already checked using two different paths. Okay, let's move on with the terminal voltage of each battery. Okay, like I mentioned before, for you to find the terminal voltage of each battery, terminal voltage only can be found at the battery. But for you to find it, make sure that the currents there is already fixed. Okay, because you want to know whether it's going to be charging or discharging. Okay, so now the only negative that I get here is only for the I1. For the I1, which means that my I1 going to be anti-clockwise. Okay, okay. But luckily enough, there's no battery here at the I1, so I don't have to be worried about that. Okay, so I'm just focused on the 45 volt here and 75 volt here. Okay, so okay, you need to see first whether the current is basically flow from positive to negative inside the circuit or negative to positive inside the circuit. Okay, because it's going to decide whether it's going to be charging or discharging. Okay, so now my I3 is moving like this, so I can actually assume it's moving like this, which is positive to negative. Therefore it's going to be charging concept. Okay, so I'm going to use formula of the terminal voltage equals to EMF minus IR. The EMF going to be 45. The terminal voltage, the internal resistance is 1 ohm, negative 1. Current I3 is 1.55, so I'm going to get my answer is 43.45 volt. Okay, so now I'm focusing on 75 volt first, but I'm going to decide whether it's charging or discharging. Right now I2 is moving like this, which means that inside the circuit is moving from lower to higher potential difference inside the circuit. Okay, I try to use the method inside the circuit in compare between the terminal because it's much easier, because I know that for the conventional current flow is going to be from positive to negative inside the circuit. Okay, for electron flow is going to be negative to positive inside the circuit. Okay, but you can actually use the method of between the terminal. Okay, it's up to you. Okay, so now I'm going to decide whether it's going to be charging or discharging. Okay, because my I2 is not negative, therefore this is the correct direction. It's moving from positive to negative inside the circuit, therefore it's going to be charging. Yes, so I'm going to use formula charging here, which is going to be terminal voltage equals to EMF minus IR. EMF is 75 minus with the internal resistance, which is 1, and my current I2 is going to be 2.411. Okay, therefore I'm going to get here is 72.6 volt. Okay. Okay, so hopefully you understand how to find the potential difference and terminal voltage. Okay, let's move on to the next question. Okay, so for question 7, okay, this one is quite different. Okay, because you can see that there's no directions of current inside the circuit, but you don't have to be worried about that. You can actually decide it. Okay, but you didn't know whether it's going to be to the right, to the left, counterclockwise or clockwise. But you don't have to be worried, because your final answer, if you get negative, it means that the direction is wrong. Okay, so now I'm going to draw here is I2. I didn't know whether it's going to be like leaving the junction or into the junction. My final answer going to decide whether my assumption here is going to be correct or wrong. So here is going to be I1. Okay, now I'm going to draw one big loop here. Okay, so it's going to be here, this one, loop. Okay, and then this is another loop. Okay, so you have two loops here, therefore you are going to have two equations. But I'm going to start with the first one. Okay, so the first one, 4 ohms here. Okay, my assumption loop and my current inside the circuit opposite, so it's going to be positive. It's going to be positive here. So 4.0 I1. Okay, there's no more here. Okay, this one, my assumption loop and my current inside the circuit also opposite, therefore it's going to be positive. The R value here is 0.50 ohm, 0.50 I2, and the EMF here going to be negative 2.0 equals to 0. Okay, so I'm going to arrange that. I'm going to get 4.0 I1 plus 0.450 I2 equals to what? 2.0. This is going to be my first equation. Okay, now I move on to the next equation. Okay, I move on to the next one. So I'm going to like try again. Okay, okay, so I'm going to draw the second assumption loop, which is going to be like that. Okay, clockwise motion. So the second loop will be here is going to be -3. Okay, it's moving from high to lower, which is my assumption loop. Okay, and then the R there is going to be positive, because my assumption loop and also the current inside the circuit, which is current that I randomly decide, opposite, so it is going to be positive 0.450 I3. Okay, and then for the 2 is going to be positive, and this one going to be negative, because my assumption loop and my directions of I2 is in the same, therefore it's going to be negative 0.450 I2 equals to what? 0. Okay, so you just rearrange everything. Supposedly you are going to get here is negative 0.450 I2 plus with the 0.450 I3 and equals to 1.0. Okay, so this is my second equation. Okay, so for me to solve it inside the calculator, therefore I need to change the unknown first. So I1, okay, I didn't have I1, so I2 is basically have in both equation, therefore I need to change either I1 or I3. Okay, I want to change I3. Okay, but for me to do that, I need to come up with the Kirchhoff currents law. Okay, so the Kirchhoff currents law going to be, so I'm going to choose this junction. Okay, so it's going to be I1 into the junction minus I2 minus I3 equals to 0. So for me to use the I3 here, therefore I'm going to get I1 minus I2. So I'm going to insert into this equation. Therefore I'm going to get negative 0.450 I2, okay, plus with the 0.450 I1 minus 0.450 I2 equals to 1.0. Okay, so once I done with that, I'm rearrange everything back, so I'm going to put it as a negative 0.450 sorry, positive 0.50 I1, okay, minus 0.900 I2 equals to 1.0. So this is going to be my third equation. Okay, so once I done with this, I'm going to put that inside the calculator, which is going to be this equation and also this one. Okay, so I'm going to get the answer for the I1 and I2 is I1 going to be 0.591 ampere, and for the I2 I'm going to get negative 0.815 ampere. Negative, it means that wrong direction, therefore the current flow should be downward. Okay, because the assumption is this one, so I should be downward. Okay, once I find that, okay, so therefore I can actually find the I3, okay, using this equation. So the I3 equals to the I1, which is 0.591 minus with the I2, minus negative 0.815. So I'm going to get, my answer is 1.406 ampere. Okay, so now the question asks you to find what is the voltage across the resistor R. Okay, so you can actually use Ohm's law, which is V equals to IR. Okay, so the I here is I1. So I1 is 0.591, and the resistor is 4. So I'm going to get my answer is 2.364 ampere. Okay, done with that. Okay, let's move on to the last question. Okay, so this one is the design is different from the previous one, but you don't have to be worried. This question also have two loops. Okay, you don't have to be worried about the voltmeter here and the ammeter here, and this two is ideal, so it means that there will be no internal resistance. Okay, so I'm going to draw two loops. Okay, so I'm going to draw two loops for this one, which means that is going to be this one. I'm going to draw it like this, and this one I'm going to draw it like this. Okay. Okay, so I'm going to focus on the red one first, which is the one going to my first loop. Okay, so the first loop for the 8 volt there is going to give you a positive because moving from lower to higher, so 8.0. And this one R, 8 ohms, okay, it's in the same direction with the I1 here, so it's going to be negative 10 I1, okay, and then this one negative 6, and then this one, because the assumption loop and the current is in the opposite, therefore I'm going to get positive 3 I3 equals to 0. So rearrange everything back, so I'm going to get plus 3 I3 equals to negative 2.0. Okay, done with the first equation. Now I'm going to find the second one, which is the green one. Okay, so the green one, I'm going to start from here, which is EMF is 13. So it's going to be positive because my assumption loop is moving from lower to higher. Okay, so like this. Okay. And then for the 3 ohm, in the same direction, okay, assumption loop and also current is in the same direction. Therefore, I get negative 3.0 I3, and the, and the 6 volt there going to be more lower to higher, so it's going to be positive 6. Okay, positive 6. Okay, so equals to 0. Okay, definitely I can find I3 because this one can be settled first. So I'm going to get my I3 here is 6.33 ampere. Okay, so once I find the I3 here, I can actually just put it inside this equation. Therefore, I can actually get for the I1. Okay, so negative 10 I1 plus 3, 6.33 equals to negative 2.0. Therefore, I can actually get it is 2.10 ampere. Okay, for me to find the I2, definitely I need to use the Kirchhoff currents law. Okay, Kirchhoff currents law. So I'm going to choose one junction for me to find the Kirchhoff, for me to find the I2. So I2 means that, example, if I use this junction, okay, or you can actually use this one, it's up to you, okay, but I want to use this one. Okay, so my I is going to be negative I1 plus I2 minus I3 equals to 0. So for me to find the I2, therefore I can just I1 plus I3. I1 is 2.10 and I3 is 6.33. Therefore, I'm going to get my answer is 8.43 ampere. Okay, so done with that. But now the question asks you to find the reading of the ideal emitter. Okay, you need to understand. Okay, so it means that you need to understand that emitter means that you measure the current flow. So emitter here, the current going to pass through the emitter going to be I2. So you already find I2 here, which means that the current flow passing through the emitter going to be 8.43 ampere. Okay, now we are going to find the voltmeter. Okay, like I mentioned before, the voltmeter means that you are going to measure the potential difference. So now the question asks you to find the potential difference at this path, which means that you can choose either you can choose this path, or you can choose this path, or you can choose this path. It's up to you. Okay, but whatever path that you choose, definitely you are going to get the same answer if your I1, I2 and I3 is correct. Okay, so example, if I want to choose, maybe I'm going to choose this one and then this one. Okay, so I'm going to start with the red one first. So here I'm going to get is 8. Okay, 8 positive 8. Okay, and then okay, I have the resistor here, which is the current flow here is I3, is in the same direction, is in the opposite direction with the I3. So plus 3, I3 is 6.33. So I'm going to get here is 26.7 volt. Okay, please make sure that you change first the directions of the current if you get the negative value of the current. Okay, if you get positive, it means that you just directly use the value. Okay, so the green one here, okay, so the 6 volt going to be positive, so 6. Okay, and the current flow is I1 here, which means that it's in the opposite direction with my assumption loop. Therefore, I'm going to get positive. R is 10 multiplied with 2.10, the value of I1 here. Okay, so I'm going to get here is 27.0 volt, which is approximately same with the first one. Okay, so that's how you find the potential difference. Okay, so hopefully this video going to help you to have a better understanding on how to use the Kirchhoff law for you to find the unknown and for you to find the terminal voltage and potential difference. Okay, so that's all for now. So thank you very much. Assalamualaikum and goodbye.